Yo, what's up? Today we're going to talk about relative dating, and that's not when you take your cousin out, but it is one way that you can tell how old a rock or a fossil might be. We ultimately will learn two ways to age fossils and rocks or vents in history. One is relative dating, the other is absolute dating. But for today, let's focus on this guy right here, relative dating. Just like the definition says, these are how we can put events in a sequence or an order, but not actually give them a number. And we're going to take a look at each of these crazy words here and figure out what they mean. But first, some background on relative dating. It does, like the first bullet says, determines if an object is older or younger. It is qualitative. So again, there's no number value given to it. It's qualitative data. You should remember this from the beginning of the year when we talked about qualitative versus quantitative. Quality, remember, when you're shopping on Amazon, it's describing the review or how good the product is, what color it is. Same thing with relative dating here. We're just giving a qualitative amount and not a quantity or numerical value. Relative dating, our third bullet here, it is less specific than absolute dating, because you're not getting that number value. It's not an exact age. Another point for relative dating is that it's less expensive, but more time efficient. So if you're out in the field, you're digging in some holes and you find some fossils or rocks, you're going to be able to apply relative dating techniques right there on the spot. Doesn't cost anything, you just have to understand it, and you can come up with some pretty quick results. Absolute dating, you're going to have to take a sample back to the lab and run tests, so it does take longer. You're also going to find that with sedimentary rocks, relative dating is much easier to use because of the strata that we find in lots of sedimentary rocks. The way they are laid down, relative dating has some rules that apply and make it easy to figure out. So speaking of these rules, principles of relative dating. These are lots of big words, but just like normal, the nerds have made up big words for really simple topics. Original horizontality just means that all rock layers are initially in horizontal layers, and they're going to stay that way unless there's any plate tectonic activity like uplifting that jacks them all up. You can see here, I can tell this layer used to be in line with this layer before this fault occurred, this crack in the earth, and it allowed this portion of the rock to move up. Superposition is one of my favorite words. Superposition! It's just how the rocks are laid down, and they're always with the oldest on the bottom and youngest on the top. If you think of a football pileup, who's been there the longest? The dude on the bottom. Same thing for rocks. This rock layer down here has been here longer than these rock layers up here. Cross-cutting relationships. This is when an igneous rock actually busts through an existing rock. We call it an igneous intrusion. It makes us look smart. But it's literally when an igneous rock or magma, is squeezed through cracks of an existing rock. So the rock had to be there first, and the igneous intrusion came second. That's important to know. Unconformity is also a new vocab word, and this is a place in the rock where there might be some information missing, but if you look at the larger picture or image, you can figure out what's missing. Let me explain some examples. Here's superposition again, showing the oldest layer on the bottom and youngest on the top. Moving over here, some neat examples of igneous intrusions. See layers 1, 2, and 3, they were there first, and layer 4 popped through right there. And then we can have these layers that were in existence, and 7, this large magma plume kind of popped in here after the other layers had formed. Down here's a great example of unconformity. And that shows you how the layers initially kind of got bent or folded here. And then over time, the surface eroded and took off some of the layering. Additional sediments came and laid on top, leaving some unconformity or gaps in the fossil history here. But because we understand the law of superposition, we got it.